you. I'm really happy to be here, but I'm noticing that my screen isn't actually up on the thing here. So, do we need? There it is. OK, great. All right. So, like she said, my name is Shannon Hughes, and I work at the Omni Group. If you've used Omni Graphel, Omni Focus, Omni Outliner, or Omni Plan, you've used one of our apps. And I'm going to tell you a story about detangling gesture recognizers in Omni Graphel for iOS. Omni Graphel is a vector-based diagramming application, and it was first shipped 18 years ago for the Mac. So it was a mature application by the time iPads first came into existence. And we've worked hard over the years to make all of the functionality that's in the Mac app come over to iOS, while also taking full advantage of the iOS platform, especially multi-touch. So our story begins once upon a time when I was fairly new to the team, and our app had a few bugs. I know this is a strange way to start a story about software development, but it did. And there were more bugs than just this, but we're going to focus on these two. These were about our gestures. Most of our gestures were working just fine, but we had a couple issues. Sometimes, rarely, but sometimes it would stop responding to most of your touch input. And then we had one gesture that just wasn't working. Now, from an accessibility standpoint, following Kaya's great talk, I do want to point out that all these gestures, like everything that you can accomplish with a gesture in the iOS app, you can also accomplish through menus and inspectors and stuff. So you can still get your stuff done. But still, we documented these gestures. We want them to be working. All right, so starting off, I had already used gesture recognizers at some point in the past. I had added a tap gesture here, or a swipe gesture, something here and there to do something. And I felt pretty confident that I knew how to handle gestures. I knew that they're all subclasses of UI gesture recognizer, and I knew that gesture recognizers are the way that you should handle touch input in your app. It makes it easy to respond to the user's touches in ways that they expect. So a tap in your app feels just like a tap everywhere else in the system. I knew that they were already built into many components. So even if you've never actually created a gesture recognizer and added it to your view, you probably have gestures in your app. If you've added a button, you've got a tap gesture. If you've used a scroll view, it's got a pan and a pinch gesture on it to do the scrolling and zooming. And I knew that the iOS SDK comes with a long list of pre-built gesture recognizers to do most of the things that you would probably usually want to do. So I had always been able to pick from that list and didn't need to create a custom subclass, although I did know that you could if you really needed to. All right, so let's pretend, for the sake of this story, that even though I had all this confidence in my prior knowledge, I went and read all the documentation first before getting started on this debugging situation. And one of the first things that you'll discover when you read the documentation is that gesture recognizers are state machines. And they come in two different flavors. There are discrete gestures and continuous gestures. And what it means for a gesture to be a state machine is that each gesture recognizer has a finite number of states, and each one is in exactly one state at any given time. And the transitions between states are based entirely on the current state and the received touch input that's coming in from the app. So let's see some examples here. We're going to see a few videos, and what you're going to see, you can get the sample app from my GitHub page if you want to play around with it. We're going to see the current state of the gesture is going to be highlighted in the diagram, and then when the gesture sends its action message to its target, the background of that diagram is going to flash blue for a second. So right now we're going to see a single tap gesture set up to recognize just a single tap, and a tap gesture that's set up to recognize a double tap. And we're going to see a single tap hit the screen. And we're going to see it on loop. Because these things go fairly fast. This is actually really slowed down from how fast it actually happens in reality, but if it went that fast, we would not be able to see anything. So what you'll notice here is that as soon as that touch lifts, the single tap gesture recognizer goes into its recognized state and sends its action message right away. And then a little bit later, the double tap gesture has been waiting for potentially a second tap to come in, doesn't get it, and moves to failed, and doesn't send any action messages. All right, so back to our story. Our first bug, the canvas stops responding to most touch input after you're trying to quickly resize an object. And it's not in the title, but in the notes, it says that this is rather tricky to reproduce. It's really an edge case. And tricky to reproduce means that we're probably going to spend some time debugging. So I went through my list of all my favorite debugging techniques. I didn't even put just regular breakpoints on here, because if you put a breakpoint in when you're trying to do gestures, like, you're just going to stop all your execution, and it's not going to help. So the first technique I ever learned, logging to the console. Nice and easy to just add a NSLog statement. And it can be useful, but if you have a whole lot of gestures, or if you're using continuous gestures, you'll probably end up with so much console spew that it's hard to actually pull out the information that you need. And also I found that since this was a tricky to reproduce situation, there was a close timing effect going on, and logging to the console slows everything down, and it actually made the bug completely disappear. Like, we could not reproduce it while logging to the console. So that wasn't so helpful. All right, so the next thing is adding sound effects to breakpoints. And this is a technique that I really love for working with an app when you want to get some insight into what's going on while you're still continuously interacting with the app. You can set the breakpoints to continue after evaluating and choose a sound. There's a whole bunch to choose from. It makes you notorious among your colleagues if you share a workspace and don't use headphones. And so anyway, I really like this technique. It often has helped a lot. But in this case, you also see timing effects, because what happens is the system stops execution of the app at the breakpoint and then plays the sound to completion and then continues. So this didn't really help so much either. So it was on to another great technique that I really love, but takes more effort because you have to write some code, visual feedback. And the reason that this works well is because the iOS system is like optimized and designed for responding to touch input and drawing to the screen. So we didn't have the timing problems. What you've got to do is just respond to your gesture messages and pull out the information that you want to display to yourself, and then in your drawRect method, put something on the screen that tells you what you want to know. All right, so with the console spewing and Xcode beeping and the screen flashing, made a discovery, and that was that, oddly enough, with a bunch of gestures on there, if we had two gestures responding to the same touches, there was no way that we could predict what order we would get those messages in. So in this case, for this bug, the problem turned out to be that we have the scroll view that holds the canvas, and that has, like I said, a pan and a pinch gesture already installed on it for its basic functionality. And then we also have a pan gesture installed on our canvas so that you can move objects around, things like that. And for this bug, what was happening is sometimes the scroll view pan was recognizing before our pan, and sometimes the other way around. All right, so what are we going to do about that? I know I'm talking about pans, but this is going to be easier to illustrate if we go back to the tap and double tap again, so that's what we're going to do. And in this case, you can see when a double tap comes in, you've got the single tap sends its message right away when it gets that first tap, and then you get the message also from the double tap gesture. And this might be great for you, it might work, but if you're trying to do something different with a single tap and a double tap, like completely different, it's going to be a little irritating to have to deal with the fact that you're going to be getting messages from both and not quite sure what you should do. So having read the documentation, I knew that there was a way to force an order on a pair of gestures. What you can do is tell one of the gestures that it needs to require the other one to fail before it can recognize. So in this case, we'll show the single tap is going to require the double tap to fail, and we'll see what that looks like. And so this is with a double tap again. So you can see the single tap still moves to the recognized state right away, but it doesn't send any messages. And the double tap then, when it recognizes, does send a message. And then the single tap knows, oh, the double tap, my friend over here, did not fail, therefore I should not do anything. All right, and that might work great for you. It definitely takes the confusion out and everything, but you are going to pay a price in this situation at least, because you're going to end up waiting to respond to your first tap. in order to see if there's going to be a second tap. So we'll see that here with just a single tap. And you can see that unlike before, when the single tap was moving to the recognized state and sending its message at exactly the same time, now it moves to its recognized state and hangs out for a second, waits for the double tap, which moves to the failed state, and then the single tap goes ahead and sends its message. Oh, and I have two things I need to tell you about these visualizations. One is that, like I said, they're much slower than actual reality. The other thing is that in order to show the transitions through the state machine, I'm doing KVO on the key value observing on the state of the gesture. And that's cool. I like these visualizations, but please don't ever ship an app like that. Gesture recognizers are designed with the target action idea, so you should register as the target and respond to the action messages. And I think by this point in the talk, you already have an idea of the kind of misery you could get yourself into by trying to respond to trying to observe the gesture itself. All right. So, our bug. Figured out the solution. We can use require to fail. We can tell the pan gesture from the scroll view that it needs to require our pan gesture to fail before it can recognize. And we've fixed the bug. All the optimism and confidence we started out with has only increased. We've had such a great success. I'm sure this next bug is going to be really easy to fix. Just one more to go. Okay, so this is going to be even easier because it's not even tricky to reproduce. This one just isn't working. So we'll be able to figure this out in no time. So what is this gesture? The bring forward, move backward gesture, this is from our documentation, says that you should touch and hold on a graphic and then swipe up or down with 2 fingers to move it forward or backward in the Z order of the layer. All right. More console spew and binging Xcode and flashing screen come to discover that the issue is we have a bunch of gestures that occasionally can look very similar to each other. So this long press and nudge that we're talking about for this gesture can also kind of look like a pinch to zoom, and all of those can also kind of look like rotation in the beginning. And so using require to fail, although maybe I tried, didn't actually, like the situation was a little too complex for that. All right. Oh, and now I need to come clean about something, because I've been talking all along like it's totally normal for all of your gestures to be responding to all of the touches at all the same time, and that's not actually the default behavior. By default, only a single gesture is going to respond to a set of touches. So to illustrate this, let's look at a pan gesture. And with just a single pan installed on the view, it doesn't matter. The pan is set up to discover when you have moved from the original location of the touch by a minimum amount. And it doesn't matter, timing does not matter to the pan. So if you touch down and wait for a long time before moving, the pan will still recognize, and if you drag immediately, the pan is also recognizing. But by default, if you add a long press gesture recognizer to the view, now you'll find out that if you wait long enough to trigger the long press gesture, which, surprise, is a continuous gesture recognizer, you will not get any messages from the pan gesture because the long press is taking all of those touches. If you do want them to both be registering at the same time, you need to implement UI gesture recognizer delegate. Specifically, the gesture recognizer should recognize simultaneously with other gesture recognizer method. And you return true, and then you get this behavior where no matter whether you sit and wait for a while or move immediately, the pan is still going to recognize like it did before, just as if it was alone on the view. And the long press, of course, behaves the way it would. It fails if you move too fast, and recognizes if you sit still for a while. All right, so this protocol, UI gesture recognizer protocol. Oh, I know. So that's great if your situation is simple. You might be thinking like, why can't I just use the default behavior and the system will decide for me which gestures I should be responding to, and everything will be great. Like, why is this a problem? And the truth is, in simple situations, it might be fine. But although even some situations that you would think are simple might not actually turn out to be as simple as you think they are. But in our case, as you just saw, it was not simple. We have a whole lot of gestures that we document in our documentation as working together on the canvas. So you can accomplish actually 18 different things by gesture-driven actions. And to make things slightly more complicated, or actually in many ways simpler, but a lot of these are not, it's not a single gesture that's been designed to map to a specific action. A lot of them are composite gestures, so we have standard stock gestures, and we're making them work together to recognize these semantic actions. So for us, hopefully that's enough hand-waving to convince you that we really did need to be recognizing gestures simultaneously. We couldn't just rely on the system to tell us which gesture we should be responding to. All right, so back to this gesture. Like I said, this one is a composite gesture. So even though we talk about it as if it's a single gesture, it's actually a standard long press and then a standard up swipe for the up and a standard down swipe for the down. So it's actually 3 gestures working together. Okay, so still, now reading the documentation and knowing about this Delegate Protocol, it seems like a really powerful tool. I've got all these options. I have not just should recognize simultaneously, but also some other methods. I could tell on the fly, I can decide whether a gesture should begin or whether it should receive a touch. And this is not an exhaustive list, but it's pretty representative. So, you know, I'm again feeling optimistic and confident that with these powerful tools, of course, we can solve this problem. All right, so go to the code and discover, oh, actually we're already using most of these. I still went ahead and added the one that we weren't yet using, just for good measure. And that didn't really quite fix it. So then started tweaking things, moving logic from one method to the other, making some tweaks. And as you can see from my commit messages, as they piled up, the waning, crumbling confidence and optimism, finally reverting everything that I'd done because too many problematic side effects. It was basically like we could make one step forward, but then we'd make maybe 2 steps backwards, or at least get nowhere. So at this point in the story, it's time for like an epiphany, right? And in our case, the epiphany, well, actually, no. First, it's time to take a step back and think, maybe we're just doing a little bit too much. Like maybe we got a little too excited, added a few too many gestures to our view. Maybe this is just impossible. But the thing is that looking at our documentation, like we were able to explain to our users and to ourselves really clearly what the app was supposed to be doing. So why couldn't we tell the app what the app was supposed to be doing, right? Perennial problem in computer science. So now it's time for an epiphany. And the epiphany in our case was, what if we didn't really need all of the gestures, absolutely all of the time? So we got everybody into a room, our UX team and our engineers and our product managers, and we talked through all the documentation, and we did a whole lot of diagramming on a whiteboard about exactly how, so that everybody was in total agreement about exactly what everything was supposed to be doing. And this is what we ended up with. Whoa, like no wonder we were having some problems. No wonder this was hard. Look at the amount of complexity we were trying to manage without even really quite realizing that that's what we were doing. So this diagram was a little bit frightening, but it was also encouraging, because what came out of it was the realization that really, yes, it's true, we don't need absolutely all of the gestures all of the time. It was also encouraging because, doesn't this look a little bit familiar? I mean, I know it's not as sweet and simple as the gesture recognizer state machines we were looking at before, but this is a state machine, and we know how to program state machines. So that's what we did. We built our own state machine, and when you're building your own state machine, there's a couple things that you need to do. You need to define the states and the allowed transitions, and that was already in that diagram, right? And you need to define what causes your state transitions. And that was actually in the diagram too. Each of those arcs had a little label on it about what was going to happen. It turned out that in almost every case for us, it was actually touch information was going to cause that transition. So what we ended up doing is dividing responsibility between the view controller is still the target of the gestures and still receives the action messages first and decides what the user meant by all that and makes the changes to the document. But also, as soon as it receives those messages, it also sends them on to our overall state machine, which uses the touch information to determine what state it should be in next. All right. Then you also need to define what happens when entering and exiting a state. And in our case, it turned out that a state really, the whole meaning of a state in this state machine for us was which gestures are turned on and which gestures are turned off. And that's actually the simplest method of dealing with gestures that I didn't even mention. There is a flag, the is-enabled flag on every gesture, and you can set it to true and false as many times as you like during the execution of your program without ever removing the gesture from the view or anything. All right, so when we move into a new state, the state machine handles all of this. The state machine turns the gestures on and off. And we actually even included the gestures that are owned by the scroll view. Our state machine turns them on and off when it's useful for us, even though they're still communicating with the scroll view just like the scroll view expects. The scroll view is none the wiser. Yeah. Okay, so when you're working with a state machine, when you're designing a state machine, that kind of diagram is really useful, and it's an intuitive way of understanding what's going on. But when it comes time to actually write some code, it can be a little difficult to keep track of where you are in a spaghetti diagram like that. So you can transfer it into a matrix, a state transition matrix. In this case, we've got the from state down the side and the to state across the top. And the gray boxes mean that those transitions are illegal. Like they can't be done, can't get here from there. And so you can start to see why this approach was so helpful, because this matrix is pretty sparse. Not all of most of the transitions are not allowed. And so that means that once we know that we're in a state, which we always do because we're a state machine, then it's pretty easy. The realm of possibility, the array of possibilities before us of what our next step could be is fairly limited. So that really helped to reduce the complexity that we were dealing with at any given time. And another way that we were reducing complexity is that now all of the deconfliction of gestures between pairs of gestures, or groups of gestures even, was now moved to the state machine and was handled simply by turning off the ones we didn't want to hear from and turning on the ones we did. So this is another matrix. It has the gestures down the side and the states across the top. And in this diagram, the filled-in circles mean that that gesture is on in that state, and the empty circles mean it's off. So if you're reading the columns up and down, you can see that there's pretty much never do we have more than half of the gestures on at any given time. So again, cuts away a lot of the complexity that we were trying to deal with. All right. We still did need a gesture delegate, and that's our view controller. And we still actually need all three of these methods, but they became a lot simpler. At some point in this whole adventure, some of these methods had become rather complicated in their logic. But now our should recognize simultaneously method simply returns true all the time. We just always let all the gestures through. And gesture recognizer should begin just handles two special cases about avoiding rotation and avoiding the text editor if the text editor is on the screen. And it's only 8 lines of code. And our should receive touch method just avoids interpreting taps from a stylus when we think that you're probably doing some handwriting, so that we don't interpret those as taps that we should do something with. And it's only 3 lines of code. So that's a lot simpler, even though we still do need the delegate. And then at some point in this, at the beginning of this process, I had hoped that maybe we could just do away entirely with custom gesture recognizers and only use the stock ones. But we do still use some. However, they are also simpler. So we don't have any direct subclasses of UI gesture recognizer anymore, so we aren't handling the raw touch information. We're still relying on super implementation from Apple for how to actually interpret the touches. We're just adding some little niceties. So for instance, we have a subclass of UI rotation gesture recognizer. Ours allows you to start a rotation just like the normal gesture, but then you can lift one finger and continue the rotation with a single finger, which is just kind of fun, first of all, and also gives you a little bit more visibility into what you're doing, and for a graphics application, that's a nice thing to have. And then we also subclassed tap gesture recognizer so that we don't have a separate single tap and a double tap gesture that we have to try to manage. Ours just counts the number of taps, sends a message for every tap, and then you can easily ask it, how many taps have occurred. So then we can give some feedback when we get the first tap immediately, and the app feels very responsive, and we don't have to worry about which one is coming next. All right. So that's the happy ending. The bug was fixed, and that was a whole lot of work to fix one bug, one little edge case bug. But the good thing is that there were a lot of benefits besides that came with this approach. Our code felt a lot less fragile, and it felt a lot easier to understand. So that gave us more confidence in fixing bugs in the future. Not that there would ever be more bugs. And it also gave us more confidence in if our UX designers came up with an idea that they thought maybe this gesture would work a little bit better if we handled it slightly differently, we felt like, yeah, sure, we can make that change because we understand how this code works, and also we feel like it's not going to have too many side effects when we try to do something. All right, so everyone lived happily ever after, always remembering that when faced with situations of daunting complexity, a state machine might help bring order out of the chaos. The end. Thank you very much. And I actually have no idea what time it is. It looks like we have a little bit of time for questions, if anybody has a question. Over here? Do we have a microphone? Oh, and there too.
Maybe just repeat my question.
Sure, yes.
Thank you. That was an awesome talk. Since you have, finite states that you define all the expected behavior and interactions between gestures, what do your tests look like?
What do our tests look like? That's a good question. I don't think that we have tests specifically for this part of the app, to be honest. We have a team of testers that work with the app. So thank you. Good question.
When you were also great talk, thank you. When you were transitioning, or when you were proposing the transition to the state machine, did you have ultimate team buy-in, or did you have to convince stakeholders to kind of spend the time to sort of rebuild the whole thing?
Yeah, that's a good question. I'm trying to remember. I mean, I think by the time we had that big meeting and drew it all on the board, it was a very collaborative process. And there were a lot of, we had our designers in there too, so not necessarily people who knew what a state machine was, but we didn't actually use the term state machine or the even scarier finite state automaton in the meeting. So I think that these kind of diagrams are fairly intuitive, especially if you're drawing it in front of somebody and they're sort of telling you, oh yeah, from there you can do this or you can't do that. So yeah, I think by the time that process was really important to getting the buy-in, but once we got through that, it was good. Thank you.
Okay. Over here.
Over here, sorry.
Sorry. Also from my side, thanks for your talk. And my question is, how long did it took you or your team to fix all these things?
That's a good question. I think the whole exploratory thing, it was probably 2 months from the beginning of picking up these bugs to finally being done with this idea. But there was other work going on at the same time. Yeah.
Thank you.
Here, okay.
So did you write any tools to be able to visualize the code and how the code runs through the state machine?
I didn't actually. Not for that gesture, not for the meta gesture state machine. What you're seeing here for the sample apps, I basically spruced up a lot what I had done for myself in the debugging phase to make these videos. But once if you're controlling the state machine, you've got your list of states, you've got total insight into it. So it hasn't. We have some logging. because the timing effects aren't a problem for us with just the one. So yeah, we haven't needed that. Thank you. Whoever gets the microphone first.
Hello.
Oh, there.
Hi. Thanks for your talk.
Thank you.
Did you run into any situations where you had to deal with the built-in like scroll view and dealing with getting rid of those or handling those in a different way?
Yeah. So like I said, initially we had a situation where we needed to tell the scroll views gesture to wait for ours to fail. So we were kind of reaching in and mucking with it that way. By the time we had this meta gesture state machine, we actually don't have any require to fail relationships anymore. So all of the deconfliction is handled by the state machine. But the state machine does turn those off and on. Like it actually reaches into the scroll view and says, what are your gestures, and finds the ones that we want to turn off or turn back on. And even in some cases, in some modes, we turn them on to needing 2 fingers to actually pan the screen so that we can have the single touch pan does something on the canvas, but if you really want to move the screen, you can use 2 fingers. So yeah.
Yep. You mentioned, and now again, that you were also enabling and disabling the gesture recognizers on the scroll view. Did you ever run into problems with that, with the scroll view not expecting stuff to be enabled or disabled?
Yeah, it didn't. You would think it would. Like, it sounds like a dangerous thing to do. And we may run into problems in the future, I don't know, but it hasn't been a problem so far. It seems like just turning them off means the scroll view just doesn't get the messages, so it just doesn't do anything. So we're just like, putting it on ice for a little while. Yeah.
Hello. Did you have any problem with memory leaks?
Memory leaks, that's the question? Yeah, I don't think so. Not that I don't recall having problems with that. Yeah.
Have you found a way to, like, when you coded it, to write it in a way that it's easy to follow in the code?
Yeah, I feel like it's pretty easy to follow. It's not actually a lot of code to write a state machine. You need to be able to check whether your transitions are valid transitions or invalid transitions, and you need to be able to run a block of code when you move into a state and know what state you're in. So we wrote this ourselves, and it's not a ton of code, and it's not hard to understand. However, there is, in GameKit, there's a GK state machine that ships with GameKit, so if you want to use that, it's great. I've used that for personal projects, too.
Hi. Just on the broader subject of visualizing your code base, I've tried to push for modeling on our particular team, and generally we find a lot of resistance because it requires a constant updating. I just want to know what sort of, how do you get around that? Because I've used Omni Graph for lots of university projects, but the whole team doesn't care about it. So,
Sure.
So how do you persuade someone to want to have their architecture visualized?
Thank you very much. So that's the initial diagram that I showed was built in Omni Graph. And it's also, honestly, it's probably a little out of date. Because we have not committed to keeping that visualization absolutely up to date. Once we had finally transitioned to the structure, we felt like the code was readable enough that having the diagram, it's sometimes helpful for testers, and it's still not that far off from reality. But that's a good question, and not something that I feel like I can offer this is exactly how you do it and when. Thank you. All right. Oh, there's one more question.
Thanks for the talk. You mentioned this amazing number of 18 gestures.
Yeah.
Do you know what the average Omni user, how many gestures are they using? And do they have alternatives instead of using a gesture?
Yes, so we do absolutely have alternatives. And I think for some things like moving or resizing an object, like you use the gesture. Almost everybody would use the gesture. But all of these things can be done through menu items and through inspectors. Yeah, so I can't speak exactly to how many of them get used, but I do know that some of them get used way more than others. Yeah. All right. Thank you.